We go and analyze a third example of FSMs, and in this particular case, just so that I can save a little bit of time, I went ahead and I said, okay, here's our circuit, and in this particular circuit, I wrote the state equations, and you can just follow them. This particular implementation is much simpler than the previous two examples. So for example, you can see that this one here, they just depend on each other. The first one is in A, just depends on X, and B depends on A, and C depends on B. And the output equation is just, I think it's C prime, and then B, and then A, and that's what you can see in here. And I also filled the state table in here. So the state table in this particular case, because I have 3 flip-flops, it's a little bit bigger. If I'm to write it with X0 or X as an input in another column, I would have had to have like 16 rows. But anyway, this particular method of writing state table is just a little bit more concise, and you can just follow it on your own pace. You can just pause the video and just do that. But anyway, I went ahead and I did this, and then I moved on to the next state, which is drawing the state diagram in a try to figure out what that particular circuit looks like. So this particular circuit, as opposed to the other one, implementation-wise looks much simpler in here. However, because I have 3 different flip-flops, that means I do have 8 different states from S0 all the way to S7. So let's try to figure out what it's doing. It looks really complicated, but anyway, I'm going to do the analysis of writing what each state means. And let's assume that we usually start with S0. So this here tells me, well, let's see. If you get a 0, okay, you stay in here. Okay, so that means I'm going just to say, and it seems to be here, you only get to it when you get a 0. It seems to be that S0 remembers 0. All right, let's see what about S. Well, the next state is actually S4 in here. So this is 0 followed by 1. Okay, let's do that. I'm just going to highlight this here. Okay, so that I know that I actually went ahead and figured out what these arrows mean. Okay, so that means S, well, I have S1, S2, S3, and let me just write it a little bit more concise so that I can fit all of them here. Here, and then S4, and then S5, and then S6, and then S7. Okay, let's figure out. Well, S4 seems to be, I've seen a 0 followed by 1. That's what it seems like. All right. Whether I come from here and then here, that's how it looks. It looks like I've seen a 0 followed by 1. Okay. Now we go from there. For example, you can see, well, after S4, if you do see a 0, you go back to S2. Okay, so you go back to here to S2. All right, so S2 seems to be, if you get a 0, you're going to go in here. If you get a 0, you go in here. So the only way you can see it is actually a 0. So I'm going to say that S2 remembers a 0. It seems to be very similar to S0 in here. All right, so I did cover that one here, so I don't have to come back to it. However, if it is a 1, okay, so here it seems to be, it's following basically 0 followed by 1 followed by 1. Okay, so that's S6 in here. It's 0 followed by 1 followed by 1. But wait a minute. This seems to be the sequence I'm looking for, because this is when the 1 actually appears, the output 1. So this is a more machine, and you can take a look in here. The output only depends on the current state. It doesn't depend on X directly, so it's a more machine. So I had to write it within the state diagram or the state circles in here, or the state units. And this is the only one where there's a 1. It's a 0, 0, 0, 0, a bunch of zeros in here. All right, so it seems to be the S6 looks for a pattern of 0 followed by 1, 1. And it seems to be that this circuit is doing that. However, I still have to analyze the rest of it just to make sure. And we're going to go from there. So we have done a 6, and let's see after the 6, if you get a 0, you're going to go in here, and it seems to be the S3. The only way you get to it is 0 followed by 0. So it seems to be the S3 is also just memorizing a 0. All right. So I believe I done this one here. What if S6 the output is 1? Well, if the output is 1, it's actually going in here. So S7 seems to be, well, you only get to it if you actually have a 1. So S7 seems to be remembering a 1 only, nothing else. Okay, so I have analyzed this particular row now and this particular one. And now I need to go through, I believe, let's do S5, for example, or we did an S6 and then we did an S3, so let's do the S3 in here. So in the S3, I can figure out what S3 does. Well, S3 seems to be, according to this one here, just memorizing 0. So I figured out what this does. Let's see, if actually you leave with 0, you go in here to S1. All right, so S1 seems to be here, this one here. And again, S1 seems to be remembering whenever you got a 0. So S1 here is also 0. So it's interesting that all these states seems to be the same. Like I can technically combine them. They just remember a bunch of zeros. Okay, and then let's say what happens if S1 gets a 1. Well, you're gonna move to S4, but wait a minute, what does S4 do? Well, S4 remembers 0 followed by 1. I already know that, so which is good, because if you go down here or here, you got a 0 and then followed by 1. And previously we said if you go from here and here and then you get a 1, you get to S4. So S4 is remembering the first 0, 1 sequence. So what's left for us? Well, I believe we have not analyzed these arrows. So let's see what it does. So S2 in here, technically, according to this, it memorizes 0, and that's exactly what I've seen in here from S5. Let's see what S5 does. So S5 is something I did not analyze. So I'm going to take a look at this S5 in here, and I'm going to say, okay, S5, if you get a 0, we'll figure out what it is. But if you get a 1, you move to S6. So that's interesting. So it's actually expecting a 1 and then goes in here. So it seems to be memorizing a 1, but wait a minute, S3 is already memorizing a 0. So this line in here is telling me S3 is memorizing a 0 and then followed by 1. So S5 seems to be memorizing 0, 1, very similar to S4. So let's double check that. Is it memorizing only 0 followed by 1? So the only way into S5 is a 1. That's the only way to do it. And it's coming from S3, that's for sure. And we have said that S3 memorizes a 0. And yes, it only gets in here when you get a 0, and that's it. So you can only get a 0 followed by 1. And that's pretty much it. Let's see what S7 in here is. Well, the only way you get to S7 is through this guy and this guy. So it only memorizes a 1, nothing else. And then if you get a 0, you go to S3, which memorizes a 0 only, and that's here. All right, so what I've done in here, I analyzed all the errors in here, and you can see it might have been tedious and I might have lost you in there, but you can do it on your own. This is just one way to analyze it. But what I came up with is really that S0, 1, 2, 3, all of them here, I technically can just put them into one like state. And there are ways to actually reduce states. I'm not going to go through it because it's a tedious process and it's not always results in some sort of a good reduction. But anyway, it seems to be that these are the same, and S4 and S5, which is here and here, seems to be just memorizing 0 followed by 1, and S6 seems to be memorizing 0 followed by 1 followed by 1, and that's about it. Nothing happens afterward. So what does this circuit do? Well, it is actually just a 0, 1, 1 sequence detector again. All right, so as a summary, what did these circuits do? Well, all of them were a 0, 1, 1 sequence detector. What does the sequence detector do? Well, it detects like an input X, which is here. You can connect it to whatever you want, but for example, let's assume it is connected to a switch. So what does it do? Well, it's looking for patterns of zeros and ones. For example, I'm going to just do it here. For example, you get 1, 0, 1, 1, 0, 1, 0, and then 0, 0, 0, 1, 1, 1. And really, it's just detecting, it's trying to look for that patterns of zeros followed by a couple of ones, zeros followed by a couple of ones, maybe zeros followed by a couple of ones. Whenever it sees it, it will output a 1. Why is it useful? And have we seen it before? You might have seen it. This is actually an implementation of a button. In this particular case in here, it's actually an implementation of a button code that I might have shared with you. What does it do? Well, let's assume that X is connected to a button, and the button is actually just saying, okay, so it's a 0, followed by 0, followed by V0, followed by 0, and then you press that button, and you wait for a couple of clock cycles, 1 and 1. What does it do? And even if you kept that button, actually press the push button, it actually detected it once, and it generates, so it converts something that looks 0 all the way to 1, it just converts it into 0 into a pulse of 1. So that's just basically a level to pulse, or you can think about it as a positive edge detector with the positive edge lasting for at least a couple of clock cycles. But anyway, all these circuits, this one here, this one here, this one here, and all their different state diagrams look a lot different. They all are 0, 1, 1 sequence detector. And as it turns out, there isn't a single way to do a finite state machines. The purpose and the reason why I'm showing you 3 examples of the same sequence detector is just to show you the differences. Some of them actually the X input appears in the output, and some of them actually do not, like the input doesn't appear in the output, and there are subtle differences. And these differences are covered with the Mealy and Moore video.